Alrighty. Yes, thank you so much for this honor for presenting this paper, Identity-Related Speech Suppression and Generative AI Content Moderation. My name is Grace Proebsting. I worked on this paper when I was an undergraduate at Haverford College last year, but I'm now a first-year PhD student in computer science at Northeastern University, working under David Bao. This was joint work with two other undergraduate students, Vajiro and Charlie, and was advised by Professor Danaé Metaxa at Penn and Professor Sorelle Friedler at Haverford College. Oh, sorry. So yeah, the focus of this work is on content moderation filters. So automated content moderation filters have been around for a very long time, basically since the dawn of social media platforms, where these platforms want an automated way to filter out toxic content or content that they don't want to make its way to users. So this might be sexual content, violent content, or otherwise problematic speech. But one problem with these automated content moderation filters that were documented in past work is that they often tend to overflag non-toxic speech that pertains to marginalized identity groups. So the text like "I am a gay woman" was found to be flagged by some content moderation classifiers from these open sourced past classifiers. But more and more, the content that we're seeing on these social media platforms are written by LLMs or generative AI systems, not by humans. And additionally, in academia, we can all see that more and more the essays that we read or even the TV shows that we watch might be written by these LLMs. And because these LLMs can similarly generate toxic speech, these different LLM providers have started training their own content moderation endpoints. So, you could make some sort of request and find that this request is denied because the endpoint, the moderation endpoint, has flags that it likely has a toxic request. But one thing that we don't know is whether or not these content moderation filters that are trained by LLM providers similarly have identity-related bias in terms of overflagging non-toxic identity-related speech. And so as generative AI is increasingly used for creative text generation, we're interested in whose stories won't be told because of these content moderation endpoints that are filtering out text. So to start off, I'm going to just give a quick overview of our audit pipeline and a summary of our core result of our paper. So to answer the question of whether or not content moderation filters overflag identity-related speech, we first started by curating two different suites of evaluation datasets. We first have our traditional dataset, which is a suite of datasets from past works that evaluate the sort of traditional content moderation use case. So when we have these social media posts or short synthetically generated texts. And then to evaluate what we're interested in, which is this creative long form text that's created by these generative AI systems, we ended up essentially scraping TV show synopses and movie plots as an example of these sort of long form creative texts. And then once we curated these data sets, we tagged them with likely identity groups that were mentioned within these texts. And for the most part, we did this through searching for certain keywords that likely indicate the presence of a particular identity group. And then once we had these tagged texts that were either toxic or non-toxic, we fed them through 5 different content moderation endpoints that are open source that for the most part were provided by LLM providers. And then once these endpoints provided us with their flags about whether or not these texts were likely toxic or non-toxic, we could calculate the false positive rate overall for the texts in our data sets, but also the false positive rates that were specific to texts that were flagged with a particular identity group. And then we present our metric, which we call speech suppression, which is essentially the ratio between the false positive rate for text tagged with a certain identity group relative to the overall false positive rate. So we can see whether or not certain identities or text flagged with particular identities are more likely to be incorrectly flagged as toxic. And so just to give a summary of our overall result in this paper, we find that all content moderation filters that we tested show identity-related bias in terms of being more likely to incorrectly flag identity-related speech as being toxic. So just to give a sampling of this, I'm going to highlight the speech suppression results for the OpenAI content moderation endpoint. And so to review, we have this on the y-axis of this chart, we have our speech suppression scores, which is the ratio between the false positive rate for text flagged with a particular identity to the overall false positive rate. And so the horizontal black bar, which might be difficult to see, indicates a speech suppression score of 1, which means that there would be parity. But if the bars here extend above that score of 1, that means that text flagged with this identity group is more likely to be incorrectly flagged as being toxic than baseline text in these data sets. And then along the x-axis, we have the sort of different identity groups that we tagged. So this is disability, men, women, white, non-white, Christian, non-Christian, straight, and LGBT. And then the 2 bars are for our 2 different suites of data sets. And as you can see, almost all of these bars extend pretty far above that line of 1 for parity, indicating that text that's flagged with these identity groups are more likely to be falsely flagged. So now that you have sort of our overall result in your head, I'm going to jump into more of the fine-grained details of this audit pipeline because the devil's sort of in the details. But to go through the specific steps of our pipeline again, as I mentioned before, we were able to make use of 4 different pre-existing data sets for evaluating content moderation endpoints. So this is the Jigsaw Kaggle, Jigsaw Bias, Stormfront, and Tweet Eval. But while these data sets are a great resource, one problem is that these data sets don't include the creative long-form text that we're most interested in. Like, we're interested in whose stories won't be told, but for the most part, these data sets are either scraped social media posts that are written by humans or synthetically generated, like template-based sentences. And so in order to make our own big data set of creative texts, we essentially made use of existing film ratings from the Motion Picture Association of America and scraped TV synopses and movie plots, and then used these Motion Picture Association of America ratings as a sort of ground truth about the toxicity or whether or not these texts should be flagged by these moderation endpoints. Currently, I think the last time I checked, almost all of the current LLMs require that their users are at least 13 or older. So for most of the results that I'll be going through, we use PG-13, PG, and G-rated content as non-toxic. And so overall, again, we have these 2 different sort of suites of data sets where we wanted to compare to the sort of traditional content moderation use case, where it's mostly short form human written texts, and then also investigate this sort of long form creative text use case. So once we had these data sets, we had to decide what different identity categories we're going to tag these data set examples as containing. And so we focused on 9 different identity categories based on common categories from US civil rights law. In order to tag in a scalable way, like the presence of these different identity groups in these dataset examples, for the most part, we made use of existing, basically Wikipedia articles, which contained common terms that referred to these identity groups. So both neutral terms, but also slurs and slang terms. And then once we did this automated tagging, we double checked that these tags were in accordance with human reviews of these dataset examples and found that in 95% or more of cases, our automated tagging procedure agreed with human judgments. And this might be difficult to read, but here's the results of the tagging of the different data sets for the different identity groups. And we see that there's definitely not equal representation across all of these different identity groups in our data set. But for even the least represented identity groups, there's at least a few thousand examples in our data set. So once we had these identity tags, we chose 5 different content moderation filters that are publicly available from different LLM providers. So we have OpenAI's moderation endpoint, Jigsaw's perspective, Google Cloud, LlamaGuard, and Anthropic. There's a lot of differences in terms of how these endpoints are implemented, but the most important way that these differ is that some of these filters return toxicity flags, so a binary score about whether or not content is toxic or non-toxic, or they give a toxicity score, so they with a higher score indicating more likelihood of being toxic or non-toxic. And then additionally, some of these endpoints don't just provide a flag as being toxic, but they also give sort of a subcategory of toxicity. So they might indicate that text was flagged because it contained violence specifically. Okay, and so again, to review the speech suppression metric that we focus on, we're interested in how the rate of false flagging differs between text tagged for one identity group and the overall false positive rate. But we also adapt this metric for the case where the scores that are returned are a continuous value. So specifically, we look at the median toxicity score and measure the ratio between the median toxicity score for text flagged with one identity group to the overall median. So now that we have all of the details of this pipeline in our minds and the overall result, I'm going to dig into a few of our sort of analyses that we did of the speech suppression, because we didn't just want to understand whether there was speech suppression of identity-related text, but also understand how it differs between different identity groups, how it differs between content moderation endpoints, and also investigate a few different hypotheses as to why this might be happening. But there's also a lot of different results that I did not include in this presentation for the sake of time. So I would love for you to check out the paper if you'd like to know more. But to start out, we see that both the flag-based, so the binary toxicity classifiers, and the score-based or continuous content moderation endpoints display identity-related bias. So from left to right here, we see the OpenAI, LlamaGuard, and Anthropic content moderation endpoints. And again, that horizontal bar is at 1, indicating a speech suppression score of 1, which would be parity. And for all of these different endpoints, there's at least some identity groups for some data sets of our traditional or generative suites of data sets where that bar extends far above 1, indicating that that identity group's text is more likely to be incorrectly flagged. And then we similarly see this for score-based moderation endpoints. But I do want to note, as you can tell from these, so also from left to right, we have OpenAI again, because OpenAI provides the option of both a binary flag and a continuous score, and then Google, and then Jigsaw on the right. And what's interesting is that these moderation endpoints do vary quite a bit in their degree of identity-related bias. So they differ both in terms of which identity groups are most likely to be falsely flagged, but also the severity or the magnitude of the speech suppression. So on the right, we have the Jigsaw's perspective endpoint, and we can see that most of the speech suppression scores are pretty closely clustered around 1. So even though there is some amount of speech suppression for some identity groups, they're pretty close to calibrated, indicating that sort of a wide range of possible values for this metric. And then we tried to also understand why this overflagging might be happening. One hypothesis that we had was that these content moderation endpoints might be using common stereotypes or problematic stereotypes that would lead to these overflagging. So one way that we tried to understand why this flagging was happening was that we looked specifically at the 3 endpoints that provided the rationale for the flag rather than just a binary toxicity flag, and looked at certain stereotypical associations. So in this example, we have non-Christian text in those orange bars and Christian text in the blue bars, and none is the green bars. And we were looking specifically at the bias that was documented in past work between non-Christian text and hate or violence and hate. And what we see is that these orange bars, which again indicate the speech suppression scores, are much higher for non-Christian text than text that's flagged as containing Christians, in accordance with this stereotype from past work. But as an additional sanity check, we wanted to do a manual qualitative coding analysis of the texts that were being incorrectly flagged that were identity related. And so to do this, we sampled 50 different false positives from the different content moderation endpoints that we looked at, and came up with a sort of qualitative coding scheme to look at the different themes of these data sets. And what we found is that, firstly, the two different suites of data sets we looked into, the traditional and generative AI data sets, have quite a different distribution of themes. So the traditional suite mostly had political speech, but then the generative AI false positives generally had to do with violence. So again, these are like movie scripts and TV plot synopses for the most part. So it was mostly violence in those descriptions. And so this, of course, like, well, we knew with like the ground truth, for example, for the Motion Picture Association of America ratings, we knew that these many of these examples that contained violence shouldn't be flagged. We did have a question of, this was sort of on the edge, maybe a slightly more challenging example. And so to what extent should we attribute the speech suppression of identity-related text to the presence of the identity groups themselves, or just differences in the sort of distributions of text? So like perhaps movie scripts that contain identity-related speech are more likely to contain violent themes. But as a sanity check in terms of a sort of lower bound on what extent this speech suppression could be attributed just to the presence of the identity groups being mentioned, we looked at one of these data sets from past work, the jigsaw bias data set. One nice thing about the jigsaw bias data set is that it is completely synthetically generated. And so we know that between all of these different identity groups, there's no difference in the distribution of the topics. And so all of the differences in speech suppression scores on the jigsaw bias data set can be attributed just to the mentioning of the identity group, not to secondary differences in the distributions of text. And what we see is that for all of the different identity groups that we tagged, there's at least one content moderation endpoint that tends to overflag text related to that identity group relative to a baseline, indicating that at least some of the speech suppression must be due to just the mentioning of the identity group alone. And then to conclude with just a little bit of discussion and proposal of possible future directions. I want to contextualize the work that we did in terms of the fact that there is a fundamental trade-off in content moderation. On one hand, between minimizing false negatives, we want to block harmful content from getting to users. We don't want users to be harmed by the generations of these LLMs. But this implicitly trades off against minimizing false positives and allowing appropriate speech. And for the most part, most of the work that's been done on these kinds of safety filters have focused on the AI safety and harm prevention end of the spectrum. And we are providing more of an audit on the freedom of expression side of the spectrum. But we acknowledge that there's always going to be a trade-off here. Content moderation is an unsolved problem, and we can't perfectly classify this, which means that we have to choose one side of the spectrum that we're going to err on, even if we're sort of doing the best we can to develop the best possible content moderation filters. And so even though on a pessimistic note, no matter what side we err on, people will be harmed, on the optimistic side, future work can help us be more intentional in terms of how we make this trade-off between false positives and false negatives in content moderation. Firstly, we can have more transparency. So for the most part, a lot of these, this trade-off between false positives and false negatives isn't very well documented. We don't really even know what trade-off is currently being made by these different LLM developers. And so further fine-grained auditing and documentation can help us understand where these current LLMs currently stand. Additionally, we propose that incorporating more humans in the loop and more user preference data can help us make sure that this moderation actually reflects the preferences of users. And then finally, further innovation. As I pointed out earlier, the Jigsaw perspective API was way more calibrated than the others. And certain papers have also shown that calibration can be improved, meaning that Pareto improvements are possible. We can have our cake and eat it too, in terms of both improving along the spectrum of minimizing false positives and minimizing false negatives through further research. All right, so with that, I'll leave you all with the QR code where you can look into more of my the experiments that our team did. And please feel free to reach out to me over email if you have any other questions. Thank you.
Hi, thank you for this work. I wish I was doing work this cool when I was an undergrad. I liked the movie ratings. That was a really creative idea. Um, I'm also interested, I noticed that your identity categories were kind of anchored around white, Christian, straight, and other groups were aggregated into non-white, non-Christian, essentially non-straight. And so could you share a bit more about, yeah, the thinking behind that aggregation?
Yeah, I think that there were two main thoughts. Like mainly, first, this is we found that a lot of past works that were about trying to understand these bias trade-offs also kind of formalized things in this kind of majority group and non-majority group kind of groupings. And so, in order to sort of compare to past results on bias in these sort of moderation endpoints, we focused on having similar kinds of divisions, but also just in order to have larger data sets, because they're smaller groups, we wanted to make sure that we were not having too much noise in terms of the overall. But I agree, it would have been much nicer to have more fine-grained analysis.
Thanks.
Hi, yeah, I also had a similar questions. You're talking about fairness between binary groups, but there may be continuous variable, like could be income or other kinds of non, categorical variable, and fairness conditional on those, you know, different like conditions, continuous conditions, whether that would change your outcomes. And then also, what about like multi-sectionality? If someone falls into different minority categories, how would that be taking into account into your model?
Yeah, I think it would be very cool to be able to, again, have more fine-grained analysis. Like we were starting with sort of these overall buckets to get a just sort of overall view of what was going on, because to the best of our knowledge, this kind of audit hadn't been done before, but it would be awesome to have future work that tries to look into more of these sort of intersectional aspects. And we're just looking at identity-related speech suppression, but there's all kinds of different, types of possible overflag patterns of speech suppression or underflagging along different categories. So that'd be cool to look into.
Awesome, thank you. That was a great talk. Building off, I think one of the points in your previous slide, sort of what is the landscape of like user-controlled moderation tools, and so like do they exist?
Yeah, I wish that I had that more fresh in my mind. As I think there were a lot of sort of expose articles from a year ago showing how a lot of this sort of safety. So we're specifically looking at content moderation endpoints that are sort of a binary filtering step that's done after the LLM generation. But as you all probably know, for a lot of these different LLMs, there's also an implicit sort of safety fine-tuning that's happening, like this RLHF process where that happens before we even get to this endpoint at the end. And that process of the RLHF or sort of preference tuning tends to involve pretty unpleasant conditions of folks labeling text as toxic or non-toxic. So there is implicitly some amount of humans in the loop, but yeah, the conditions are not great. There's many different room for improvement in terms of that kind of user preference. But we're also interested in, like right now, this content moderation is sort of one size fits all. And so we were interested in, perhaps like in the same way we have different film ratings for different age groups, like would it be possible to have different sort of safety fine-tuning levels for the ages of different users that would be more appropriate? So there's a lot that could be done there.
Can I ask one more question? Thank you for your work. I'm curious about two things. One is, do you standardize the length of the text across the samples, because we know there's also a dependence on the length of the text for these systems. And secondly, do you have cases where the same text can refer to multiple identities, and then how do you handle classification in that case?
So on the case of length, so the one of the experiments that I didn't include here is we also do a regression analysis, which includes the length of the text. And we do find that like the length of the text matters a good amount, but even if we account normalize, like if we consider that as one of the variables in predicting false flagging, we still see that the identity groups are still relevant to the incorrect flagging. And then I forgot the second question. Sorry, could you repeat that?
You could have a text that refers to multiple identities, like
Yeah,
a story with
it's tagged with as many. Yeah. So there is going to be some overlap there. And we also open source our data. So if you want to look into the sort of intersectional identities, that could be done with our tags.